Welcome, everyone. I am so glad you could join us for another deep dive today. We have a mission that is, frankly, going to bend your mind a little bit.
Yeah, it's a big one today.
It really is. We are exploring a profoundly new framework in physics. It is called John Onamisi Obede's Theory of Entropicity, or ToE for short.
Right.
And to do this, we are pulling from a really fascinating stack of source material. We have a beautifully dense analytical text that explores Obede's hypothesis.
And argues that it remarkably fulfills Albert Einstein's final unachieved dreams for theoretical physics.
Exactly. And alongside that, we also have this cinematic story description. It's essentially a visual script that attempts to map out what Obede's theory actually looks like in practice.
It is, it's a heavy stack of material to go through, but incredibly rewarding. I mean, we are looking at a fundamental shift in how we understand the basic building blocks of reality. It challenges assumptions that physics has relied on for, nearly a century.
Yes, exactly. And to set the stage for you, the listener, I want you to imagine the scene laid out in that cinematic script.
It's a great visual.
It is. Picture the early universe. It is vast. It is dark. It is completely untouched by any human eye or, any conscious observer of any kind.
Just raw physics.
Right. Galaxies are violently swirling into being. Stars are igniting in the void. Planets are slowly coalescing from clouds of dust and gas. Now, here's the incredibly strange question that quantum physics has wrestled with for decades.
Did all of that cosmic architecture actually happen if no one was there to observe it?
Yes. Because traditional quantum mechanics, specifically the standard interpretations we've all grown up with, often hints that reality itself requires an observer to exist.
Which sounds absurd when you say it out loud.
Totally. But Obede's theory vehemently disagrees. Okay, let's unpack this.
To really grasp what Obede is doing here, we have to understand the core concept of his theory of entropicity. Obede argues that the cosmos is an objective, self-organizing continuum. The universe is not a stage that only lights up when we walk into the room.
It doesn't need us.
It absolutely does not depend on our eyes, our instruments, or human consciousness to make it real.
Well,
It is a universe that is evolving and writing its own laws into the fabric of existence, completely independent of us.
which, to anyone walking down the street, feels like common sense. Obviously, the universe was there before we evolved to look at it.
You would think so.
But if you follow physics, you know we've been stuck with the Copenhagen interpretation for a long time. We all know the headache of it, the idea that a quantum system sits in a ghostly superposition of probabilities.
And it's the actual act of measurement, the observation, that forces the wave function to collapse into a single reality.
Right.
Precisely.
Yeah.
And that specific idea has always deeply bothered classical physicists. I mean, it implies that before a measurement is made, the universe is just a smear of mathematical probabilities.
Just floating math.
Exactly. It lacks a foundational objective reality.
Yeah.
In that view, reality is entirely observer-dependent.
It essentially makes it sound like human consciousness is some sort of magical ingredient, like we're casting a spell on the universe to force it to make up its mind.
Yes, the magical observer.
But reading through Obede's paper, it's wild to see how he replaces the observer with what he calls an entropic force field.
A physical mechanism.
Right. He argues that wave functions do not collapse instantaneously, and they certainly don't collapse because a human made a measurement. Instead, this collapse is a sequential, deterministic process driven by entropy.
Yes. What's fascinating here is that existence is not predicated on observation at all. In Obede's framework, entropy itself is the architect of reality. The entropic field evolves, stabilizes, and resolves those quantum possibilities into concrete structure over time.
Wait, hold on, I have to stop you there.
Sure.
Because anyone who took high school physics knows entropy as the universal law of decay.
The second law of thermodynamics.
Right. It's the dropped coffee mug shattering, the ice melting, the engine losing heat. It's disorder. So how on earth is Obede using entropy to build structure rather than destroy it?
That is the crucial paradigm shift in the theory. We are so used to thinking of entropy purely as degradation.
Right, things falling apart.
But Obede asks us to look at it as a mechanism of resolution. Think of a quantum superposition, multiple conflicting probabilities existing at once.
Okay.
Think of that as a state of high tension or unstable potential. For the universe to function, that tension has to be resolved.
It can't stay tense forever.
Exactly. In Obede's model, the entropic force field drives the system toward a definitive resolved state. It relaxes the quantum possibilities into a single, concrete, classical reality.
Oh, I see.
The collapse of the wave function isn't a magical vanishing act caused by an eyeball. It is an entropic process. It is the universe shedding the disorder of infinite possibilities to settle into the order of a definitive physical structure.
Okay, that actually makes a lot of sense. The universe is essentially finding its most stable footing, and the force pushing it into that stable stance is entropy.
Entropy.
Here's where it gets really interesting. Because this deep discomfort with the magical observer and the reliance on random chance was famously shared by Albert Einstein.
Oh, absolutely.
Reading through the analytical text, it's incredible how OBD essentially throws Einstein a lifeline from the future. The text outlines how OBD's theory rescues Einstein's legacy in quantum physics across several major fronts. Let's dig into those pillars.
We should. Because Einstein intuitively hated the randomness of standard quantum theory. His debates with Niels Bohr are legendary.
Yeah, they really went at it.
They did. Einstein's position was always that quantum mechanics, with all its inherent probabilities, had to be incomplete. He felt that the randomness we were calculating just meant our math was missing something fundamental.
The hidden variables.
Yes. He believed there had to be underlying mechanisms that explain quantum events deterministically, rather than leaving them up to statistical chance.
Right, but for decades, physicists have been looking for those hidden variables, like some tiny undetected particle pulling the strings.
And they never found them.
Exactly. Bell's theorem basically proved they couldn't exist in the way we thought. So how does OBD solve this incompleteness problem without just inventing a magical hidden particle?
By proposing that the hidden variable isn't a particle at all, it is a field. OBD provides this exact missing mechanism as the entropic force field itself. It acts as a deterministic, guiding layer of reality that we simply haven't been factoring into our quantum equations.
So it's been there the whole time?
Standard quantum mechanics looks at the probabilities and says, well, it's just random. OBD says, no, it appears random because you aren't calculating the entropic constraints acting on the system.
So the underlying order is there. We just couldn't see the field enforcing it. Which brings us to the second pillar, and the most famous critique Einstein ever leveled at quantum mechanics.
I know exactly what you're going to say.
God does not play dice.
There it is.
He just could not stomach a universe acting like a casino.
And that quote perfectly epitomizes his philosophical block. Einstein simply could not accept a universe fundamentally governed by probabilistic outcomes.
Right.
OBD's entropic model answers this by replacing that chance with entropy as the grand ordering principle. When a wave function collapses, it isn't rolling a cosmic die to decide where an electron will end up.
It's following rule.
It is being meticulously guided by entropic rules.
But if it's not rolling dice and it's being guided by an entropic field, how does OBD handle the really weird stuff? This is the third pillar, entanglement.
Right, the spooky action.
Einstein famously called it spooky action at a distance. This was his EPR paradox argument. If you have two entangled particles, standard quantum mechanics says that measuring one instantly forces the other to take a corresponding state.
Even if it's on the other side of the universe.
Yes. Einstein hated that because it implies information is traveling faster than the speed of light. If OBD's field is deterministic, how does it manage that connection without breaking the speed limit of the universe? Are these entropic constraints traveling between the particles, or are they already baked into the space?
That is the exact right question to ask. OBD's hypothesis addresses the spookiness by fundamentally removing the instantaneous part of the equation.
Okay, how?
According to his theory, entropic constraints propagate in a structured field-like manner. It is not an instant, magical telepathic connection that ignores the speed of light.
But wait, if we measure particle A here on Earth...
And particle B is on Mars.
Right. Standard tests show they correlate immediately. If the entropic field isn't sending a faster-than-light signal, how do they match up?
Because the relationship between them was established by the entropic field at the moment of their entanglement. And that field governs their evolution over time.
Ah, I see.
Think of it less like a signal being sent at the moment of measurement, and more like an underlying structural web that both particles belong to.
So the instructions were already there?
Exactly. The wave function collapse, in OBD's model, is sequential and non-instantaneous. The entropic field enforces these correlations through its own evolving structure. It preserves causality. It frames these non-local connections, not as instantaneous magic leaping across the void, but as deterministic, synchronized effects unfolding within a vast, entropically connected continuum.
I see. So instead of two telepathic people instantly knowing what the other is thinking across the globe, they are both just reading from the exact same incredibly long, slowly unfolding script.
A script that was written by the entropic field when they were first entangled.
That is a brilliant way to picture it. And that non-local web you just mentioned actually ties into the fourth pillar. It solves another massive headache Einstein had with the standard model. It moves us beyond the Copenhagen interpretation entirely.
Right, his desire for an objective reality.
Exactly. He famously asked his colleagues if they really believed the moon only existed when they looked at it.
Which is such a brilliant, biting question.
It really is.
By positing that entropy is what governs wave collapse, that it is a field-driven physical process rather than an observer-induced mental event. OBD completely aligns with Einstein's desire for a mind-independent universe.
The moon is there.
The moon is there. Entropy acts as the fundamental ordering principle. Any influence an observer has is entirely secondary to and a byproduct of entropic causality. The universe is actively constructing itself.
The universe is doing its own thing, writing its own rules, whether we bring our measuring tapes and microscopes or not. But bringing this back to Einstein's personal tastes in physics, the fifth pillar. He really loved the classical world, didn't he?
He was a classical physicist at heart.
The world of planets orbiting, gravity acting smoothly, apples falling. It was orderly, continuous, and predictable. From what I understand in the analytical text, he deeply struggled to reconcile that beautiful, smooth universe with the unpredictable, discrete, jerky jumps of quantum theory.
He did. The leap from continuous classical mechanics to quantized discrete energy levels felt mathematically jarring to him.
Just conceptually messy.
Very messy. And this is where OBD's use of thermodynamics becomes a brilliant bridge. His model respects Einstein's classical intuition by suggesting that quantum events aren't actually these abrupt, disjointed probabilistic jumps.
How so? If an electron jumps from one energy state to another, standard physics says it doesn't exist in the space between. It just jumps.
Yes.
How does an entropic field smooth that out?
By suggesting that the jump is an emergent property of a continuous underlying process. Think of it like water boiling.
Okay.
The bubbles seem to appear abruptly, discretely.
Yeah.
But they are the result of a continuous buildup of thermal energy and entropic pressure.
Oh, that's good.
OBD proposes that quantum events emerge from a continuous entropic ordering. The field itself is continuous, even if the resulting physical manifestations appear quantized to our instruments.
It creates a connection.
A profound connection between quantum behavior and thermodynamics. It suggests a true continuum where the classical world and the quantum world finally meet, bridged by the flow of entropy.
So it's like smoothing out the jagged pixels in a low-res image until you realize it's actually a perfect, continuous photograph. We just couldn't see the underlying gradient.
It's a great analogy.
That is incredible. And if we follow that logic, it brings us to the sixth pillar, the absolute main event of this source material, the holy grail of modern science.
The tension between general relativity and quantum mechanics.
Yes, the great divide. Relativity relies entirely on deterministic causality and a finite speed of information transfer, the speed of light.
Right.
It is a smooth, continuous geometric theory of space and time. Traditional quantum mechanics, with its instantaneous wave collapses and seemingly non-local correlations, creates a massive contradiction.
You cannot have instantaneous physical changes in a universe governed by relativity. The math completely breaks down.
But if OBD is right, if entropy imposes deterministic constraints that propagate over time, and if wave collapse is actually sequential rather than instant,
then there is no violation of relativity.
wow.
OBD's model says collapse is non-instantaneous. It takes time, governed by the entropic field. This potentially aligns quantum behavior entirely with relativistic causality.
Because it adheres to a finite propagation rate.
Exactly, for information transfer. If this hypothesis holds under rigorous mathematical scrutiny, OBD's framework provides a genuine mechanical path to integrate quantum mechanics with relativity.
Marrying the physics of the incredibly massive with the physics of the unimaginably tiny, and all through the invisible power of entropy.
It essentially means the universe isn't schizophrenic.
Right.
It operates on one unified, deterministic set of rules.
Which perfectly sets up the seventh and final pillar, determinism.
Yes, and that is the ultimate validation of Einstein's deepest worldview. He was profoundly committed to the idea that every physical phenomenon has a rational explanation rooted in causality.
Even if our current models are too primitive to understand it.
Exactly. By attributing the ultimate ordering of reality to an entropic force field, OBD's model delivers that causal, comprehensible cosmos. It removes randomness as a fundamental, localized aspect of nature.
And replaces it with a predictable, evolving foundation. So what does this all mean? We've just spent a lot of time journeying through the most complex, abstract layers of theoretical physics. We talked about wave collapses, EPR paradoxes, and thermodynamic bridges.
There's a lot to take in.
It really is. For you listening right now, whether you're commuting to work or just hanging out at home, why should this massive shift in theoretical physics matter to your everyday life?
I believe it matters because it fundamentally shifts our philosophical place in the cosmos. For decades, popular science and certain interpretations of quantum mechanics have quietly whispered to us that human consciousness is somehow special.
Like we're the main characters.
Right. That we are the magical ingredient required to make reality solid. That without us looking, the universe is just a haze.
Yeah.
OBD's theory teaches us something entirely different, and frankly much more grounding. It teaches us that human consciousness is not the creator of reality. We are simply one of its late-arriving consequences.
That cinematic source we read captured this so perfectly. It described the universe evolving relentlessly across billions of years. Supernovas exploding, black holes forming, entire galaxies colliding.
With none of it requiring our presence or our permission to happen.
Exactly. The universe is not fragile. It is not waiting in a state of suspended animation for us to open our eyes. There is a specific quote from the text that I just can't stop thinking about.
Ah, the one.
We are not the authors of the cosmos. We are its readers.
It is a beautifully succinct way to put it.
Yeah.
OBD's framework offers us a unique blend of humility and wonder. It humbles us by revealing a vast, ancient, self-sustaining universe that absolutely does not need us to exist. Its entropic field was doing the heavy lifting of building reality long before life sparked on Earth.
And yet it gives us wonder.
Yet it fills us with wonder
Right.
because we realize that we need the universe. We need its incredibly precise, deterministic entropic order to be able to exist, to observe, and to understand anything at all.
We are the universe experiencing itself, absolutely, but we did not build the stage.
The entropic field did.
To sum up this incredible journey we've been on today, John Obedi's theory of entropicity takes the universe we thought we knew. One built on statistical disorder, random chance, and ghostly probabilities that seemingly need a human observer to become real, and flips the script.
It really does.
It replaces that randomness with a fundamental, continuously evolving, ordering force. Entropy isn't just the law of things falling apart.
Yeah.
In Obedi's view, it is the architect of structure, relaxing quantum tension into concrete reality. This theory bridges the massive gap between the jagged jumps of quantum mechanics and the smooth continuum of Einstein's classical physics. It reaches back through time, validates Albert Einstein's deepest doubts about a dice-playing God, and presents a viable, deterministic path toward a unified theory of physics.
It truly is a paradigm shift of the highest order.
Yeah.
But if we connect this to the bigger picture, this raises an important question.
Oh, here we go.
One that pushes far past what we've discussed today, and frankly, into some slightly eerie territory. Obedi's theory tells us that the universe is entirely driven by this entropic force field, a field that continuously evolves, stabilizes, and resolves quantum possibilities into concrete structure over time.
Right.
But entropy, by its very definition in standard physics,
Yeah.
flows relentlessly toward a maximum state, a state of equilibrium.
Right, the ultimate unwinding, the heat death.
Exactly.
Yeah.
So what happens in the unfathomably distant future when the universe reaches absolute maximum entropy?
Yeah.
If the entropic field has fully stabilized, and there are simply no more quantum possibilities, no more high-tension superpositions left to resolve, does the unfolding of reality simply freeze?
That is.
When the architect has finally resolved every possibility and reached perfect structural equilibrium, does it lay down its tools forever? Does time, as a mechanism of change, simply stop?
Wow. A universe frozen in maximum entropy with no more possibilities left to resolve. A completed script where no more pages can be turned. That is something profound to chew on as you go about the rest of your day. Thank you so much for joining us on this mind-boggling deep dive into OBD's universe. Remember to keep looking up, keep questioning the reality around you, and never stop exploring. We'll catch you on the next deep dive.